Hi everyone, welcome to my triple beam balance day. Alright, well I have here a way of measuring the mass of an object with the metric system. As you can see, it gets its name because a triple beam balance has 1, 2, 3 beams that go across it. And what a triple beam balance does is it uses a set of weights that are attached to it already, and that's how it's able to compare the mass of whatever object it is that you're finding the mass of compared to these weights. And that's why it's so specific compared to just finding the weight of the object, where often you're using something like a spring or something like that that depends on gravity. A triple beam balance technically actually uses gravity too. If there's no gravity, it won't work. But the difference is the triple beam balance, remember, it works here on Earth. If you took this particular triple beam balance all the way to the moon, and let's say you wanted to find the mass of a giant penny, right? Well, it would actually be the same. Now, the way that it works, right, is first there is the really large weight in the middle right here, right? Then there's a smaller weight kind of towards the back, and then finally you get a teensy weensy little weight right here in the front. And you always use them in that same order. You're always starting with the biggest one, going to the smallest or next smallest one, and then to the teeny weeny one at the very end, last for it. So let's actually measure some things so you can practice with this. So if I put our big weight on there, well, you can see the end of the triple beam balance goes up, right? So look, if I take it off, well, then it kind of meanders itself back down towards the center. This one's not quite perfectly aligned. If I kind of twist the little knobby over here, there we go. It gets it, there we go. That's pretty good. That's pretty much lined up right there perfectly. So again, we put one of the objects on there. The official way of measuring it is you start with the really big slider, and you've got to slide the big one over into these notches right here. So it'd be incorrect if I slid it and it was kind of like in the middle right here. That's not going to give you a number. You slide it to the big one. Now in this case though, I slid it over, and look, now our pointer is all the way down, right? That means that this is too heavy, right? This weight right here, it's more than the mass of the actual penny. So we slide it back and start over again, right? We move over to the next one. If I slide this guy over, meaning it's 10 grams, well, it's still pointed up over here. So we know that this penny right here is more than 10 grams because it's not a regular penny. I move it over to the next notch. See, there's still notches. Still up, so we know it's more than, what is that, 20 grams. Move it over one more time to 30, still up. 40, still up. 50, this is a big penny right here. 60 grams. Oh, it's still up, but it's getting closer. I can tell 70. Now look, now 70. So I know that this penny, it's between 60 grams and 70 grams. So if I move it back over, okay, it goes back up. But now we get to the little guy. And the difference with the little one is that you can put this one anywhere you want to be precise, right? In fact, sometimes I tell people if you use like a pen or a pencil, it actually gets it, it's a little bit easier to move it than with your finger because you bump it around. So we know when we're reading it that this penny right here is going to be 60 grams plus 1, 2, 3, 4, 5, 6 grams. So we know it's at least 66 grams. But it's still, let's see here, oh, it's a little bit over. So if I move it back this way, let's go right to 66 grams if I could get this. And then we'll see, is it aligned? It's looking like that looks like that might be it. Oh, maybe we'll say 66.1. There we go, okay. So it's gonna be 66.1 grams is gonna be the mass of this penny right there. And that's how you find the mass of an object with the triple beam balance. Let's practice with a couple other ones. Okay, so I have my giant penny right there. What if we did, well, let's say SpongeBob. All right, how about this? I've got SpongeBob right here. If I put SpongeBob on there, now officially you're supposed to reset the triple beam balance before you start. So we can go like this and okay, look, there he's up there. So we know this side is heavier than this side over here. And then I'm gonna just guess that it's not over 100 grams because this is lighter than the penny was. So let's just start with this one over here. All right, it's at least 10 grams, 20 grams, it's at least 30 grams, 40 grams, 50. Okay, he's between 40 and 50 grams as far as the mass of SpongeBob goes. So we know that, and then we'll move over the little one. Let's see here. Okay, we're moving down. It's gonna be about 43. I don't know if it would make it to 44. No, it's not gonna make it to 44. In fact, it's looking like right about here. Yeah, so that's looking pretty good. So let's see here. It's going to be 43.5 43.6 grams. All right, so SpongeBob is 43.6 grams. Good job, SpongeBob. Let's try, what else can we, oh, how about this? I don't know if this is the very first iPhone ever made, but I mean, it's pretty old, and I mean, okay, it's pretty crusty, this iPhone. But if I put that one on top there, well, look, okay, this one's gonna be heavy. So let's see if it's 90 grams or 100 grams. Okay, it's more than 100 grams. So if I kind of slide this guy over, we know it's more than 100. Let's see, is it at least 200 grams? No, it's not 200 grams. So then we slide over, so we're at 100. Let's slide this guy over. It's less than 70, less than 60, 50, 40. It's getting close. Okay, it's 100. Let's look here. It's at least 130 grams. Oh, 0.3, 133 grams. Let's move it over. Let's see here. Okay, it's getting closer. It's getting closer. So we've got what? 130 grams. 138 grams. Is it 139 grams? No, it's not 139 grams. So let's say 138.5 grams. We're kind of getting down to the end here. Not quite. 100 and I don't know. 138.2. Let's see. Oh yeah, I'm gonna call it 138.2 grams is this super duper old iPhone. Should we try something else? Let's try another one. We kind of reset everybody here, is what you technically should always do at the beginning. How about this? Okay, let's time ourselves. We can see if we can do it in less than, I have no idea how long this timer is. Okay, so I'm gonna guess it's less than 100 grams here. 10 grams, and it's looking like it's moving already, so let's say it's gonna be 10, 11 grams. Oh, it might only be like 11 grams. All right, as time's ticking away here and everything, we're at 10, 11 grams, and oh, it's close, it's close. Wait, maybe if I move this over just a tiny bit. It's looking like it's gonna be 10.9 grams. 10.9 grams is our timer that we have right there. We'll do one last one. All right, so one last one. Goodbye, timer. Let's do Mr. Banana right here, all right? So we reset everything, put Mr. Banana on there. Mr. Banana is not very much mass at all. In fact, I'm just even gonna guess that it's less than 10 grams. Maybe, let's see. Oh, I might have guessed wrong. I might have guessed wrong. Yep, okay, he's at least 10 grams. But over here we have 20 grams, so we know he's less than 20, so we'll go in the middle. No. Okay, here we go. He's 10 grams, but not off, so it's 11 grams. Let's say this is 12 grams right here. So we're at 10, 11, 12 grams. And, oh, it's just a little bit over. It looks like it's just a hair over right here and everything. So if I move it to 11.9 grams, let's see, 11.9 grams. That is looking just about perfect for our triple beam balance. So we're gonna call it. The banana is, look, it's 10, 11.9, oops, I missed it, but 11.9 grams is what the banana is gonna be. All right, and that is how you use the triple beam balance.